first step to find the electron's final velocity is to find the acceleration of the electron. There is only one force acting on the electron, which is the negative plate below it, which causes the electron to move upwards. We can find the acceleration of the proton using Newton's second law, which states that the sum of all forces is equal to the mass of the object multiplied by the acceleration. Thus, we can rearrange the equation to find the acceleration. The sum of all forces is equal to the electric force, and the mass of the electron is given to us. The electric force is equal to the charge on the particle multiplied by the field intensity. Thus, we can sub this in for the sum of all forces and divide this by the mass to solve for the acceleration. The next step is to find the amount of time that the particle will take to pass through the plates. For this step, we can use the basic kinematic equation of velocity is equal to the displacement divided by the time. We can rearrange this to solve for time by dividing displacement by the initial velocity, which is given to us. The final step is to then use another basic kinematic equation to solve for the final vertical velocity. We will use the equation acceleration is equal to velocity divided by time. We can then rearrange this equation to solve for the final vertical velocity. To find the final velocity of the electron, we will need the vertical and horizontal components of the velocity. We know the horizontal component of the velocity, which was provided for us, and we just found the vertical component in part A. We can now use the Pythagorean theorem to solve for the final velocity of the electron. The last and final step is to find the angle that the final velocity vector is aimed at from the x-axis. To find this, we must use the horizontal and vertical components of the velocity. We then use the tan trigonometric ratio to solve for the missing angle.